Okay, welcome to Accelerated Math. Solve absolute value inequalities. Okay, so solving them, we're not going to put it on number lines, just trying to solve it and find out in terms of x. Alright, I started with a relatively simple one here. And the first step in this thing is always going to be to isolate the absolute value portion. And this one already has it isolated, so I want to start with this. It says this all is greater than or equal to 2. Alright, I'm going to mispronounce this. Greater. I'm going to misspell it. And that just helps me remember greater then is going to be an or kind of a statement, and I'll show you how that works. Either 4x minus 3 is greater than or equal to 2, or 4x minus 3 is less than, I'm going to flip the symbol and change the sign of the number after it, is equal to negative 2. Alright, and then I'm going to solve each one of these by doing the same steps to both at the same time. And so plus 3 to both sides, so I'm just going to isolate x at this point. So I got 4x greater than or equal to 5 on this side. Over here I got 4x is less than or equal to positive 1. Watch your signs there, positives and negatives. Divide by 4, that cancels it out. I was dividing by a positive, so it doesn't make the symbol flip. So x is greater than or equal to 5/4, or, that's going to be important, divide by 4, x is less than or equal to 1/4. So being an or statement like this, it's going to, you're going to look up here and you're going to find I've got two or statements. That's what we're looking for. And which one fits? We said it had to be less than. I threw in the equals, didn't I? Yeah, no, this is right. Okay, so this one's not right because it didn't have the or equal to part. So it's this one over here. Alright, that threw me off for a second. Okay, alright, let's take a look at one. That was a greater than. This one is a less than symbol, and my answers look a little strange. I've got this weird little notation in here that just says x, such that x is an element of all real numbers, and then they give the condition over here about those real numbers. So this part right here, honestly, in this context, did not really narrow it down. It just said that x is part of the real number system. That's all that's saying. X such that x is an element, that E looking symbol, an element of all real numbers. And yeah, okay, so anyway, it's just some mathematician's way of saying, hey, x is part of the real number thing, and here's a limitation on it. And the limitation is that x is either in between negative 13 and negative 1, or in this case, it's less than or equal to negative 13, or greater than or equal to negative 1. Let's see how we do this. Alright, so here's our equation again. It's already isolated, and it is a less than, I'm misspelling than and mispronouncing on purpose, because on this one I'm going to split it up into two. I'm going to say x plus 7 is less than or equal to 6, and it's an and statement, x plus 7 is less than or equal to, I should have flipped that symbol, change the inequality, and change the sign of this. Now, some people are also going to say that, you know what, you could have done that this way. X plus 7 is less than or equal to 6, and it's greater than or equal to negative 6. Do you see how I did that? I wrote that where it's really in between those two, and that is the way it is. I kind of like doing it this way, and you'll see in just a second. I'm going to subtract 7 from all three sides. It's like solving two equations in one. I get x less than or equal to negative 1 over here, and less than or equal to negative 13. Watch your negative positive type of math. That's negative 6 minus 7. You change this, change that, you get negative 13. That's kind of cool because that's the answer. If you do it this other way up here, you get the same thing, but then you have to piece it together, and I kind of like doing it all in one swoop there. So you get this plus the and this, and then you kind of have to piece it back together. So the answer comes right out like that. Alright. By the way, this symbol over here means that there's no solution, and we'll see that one in a second, I believe. Aha! Here's one. It's already been isolated. It's saying the absolute value of x plus 4 is less than or equal to negative 2. Well, if you understand absolute value is the distance from 0. Alright, so what's the absolute value of positive 2? How far is it from 0? It's 2. What's the absolute value of negative 2? Well, it's also 2 units away. I know it's 2 to the left instead of 2 to the right, but it's still 2 units. Absolute value is defined as how far, the distance it is from 0. Distance is always represented in a positive. So in this particular statement, it's saying the absolute value of, I don't care what it says in there, the absolute value, it's saying it's going to be something related to a negative. Let's watch out. Let's see what happens here. Can the absolute value actually be less than a negative or even equal to a negative? No. So this one is not even valid. There's no solution to it. Now I want to watch out a little bit. If it had said that it was greater than or equal to a negative 2, then that would be a whole different ball game. Absolute value can't be equal to a negative, but can it be greater than a negative? Absolutely. No pun intended there. It can be greater than a negative. In fact, absolute value is always greater than a negative. So if you get one of these absolute value statements and it says it's greater than a negative, don't be fooled. Don't jump on that no solution thing. Jump on that all real numbers. It'll probably be represented either with the statement all real numbers, or maybe this kind of funky looking R thing, or that bold R or something like that. It's saying any number will fit. Well, that's true. You can put any number in here for x and get the add 4 to it and get the absolute value, and it will be greater than negative 2. I think that's all I have for you. Let me see. It is. All right. Have fun with it.